Welcome to the deep dive. We're diving into the world of natural language processing today, NLP, the tech behind those voice assistants, and chatbots. It's basically computers understanding us, and it's more mind-blowing than you might think.
It really is. It's like bridging this gap
Mm-hmm.
between how we talk as humans and how computers think. If we're talking about machines, grasping the little things, the nuances of language, from like the actual meaning of words to tone and context, how we express ourselves.
Okay, so we've got a lot to cover. Academic papers, articles, even a video from those TensorFlow folks. This is going to be a deep dive for sure.
Exactly. And the goal is to get you up to speed quick, but without, losing the good stuff, the depth.
Love that. And what's really fascinating is how much NLP is already around us. I mean, it's everywhere. Translating languages, summarizing documents. It's changing how we work and interact with the world, even.
Absolutely.
So let's start with the basics. What exactly is NLP?
So at its core, it's a part of AI, artificial intelligence, and it focuses on how computers and human language interact. It's giving machines the tools to process words, but not just that, to actually understand them, interpret them, and even generate language, their own language, in a way that we get as humans.
Right, because human language, it's not exactly straightforward. I mean, think about it. Slang, idioms, sarcasm, all those things that make us, well, us. So how do you even begin to, teach a computer to get all of that?
That's where it gets interesting. One of the first things we use, a foundational technique, is tokenization, basically breaking language down into smaller bits, like words or phrases. Imagine a sentence, and you chop it up into pieces a computer can then work with.
So it's like giving the computer building blocks to play with.
Exactly. And then we have these tokens. We use all sorts of techniques to figure out what they mean and how they relate to each other. For example, there's part of speech tagging, labeling each word, like is it a noun, verb, adjective, to understand the grammar of the sentence.
So it's like a little tag for each word, telling the computer its job in the sentence. It's like grammar lessons for computers.
Exactly. And then there's named entity recognition. That's about finding and classifying important stuff in the text. People, places, organizations, dates. Super useful for getting information out, summarizing, all sorts of things.
So if I'm reading, let's say, a news article about a company's earnings, this named entity recognition could pick out the company name, the CEO, the important numbers.
Precisely. And all of this analysis, it's driven by machine learning. We're talking algorithms that learn from huge amounts of data. I mean, think the entire internet, and they get better over time at understanding how we talk, all the nuances.
That's wild. So they're learning from us, our conversations, books, everything, constantly absorbing and refining their understanding.
That's exactly it. And one of the big breakthroughs lately has been neural networks, these incredibly powerful models.
Neural networks. I hear that a lot, but I'll admit it still sounds kind of sci-fi to me. What are they really?
Imagine a network of nodes, all connected. Each one is like a tiny processor, and they're organized in layers. Information flows through, like signals in our brains. By tweaking the connections between these nodes, the network learns from data and gets better at specific tasks, like spotting patterns in language or translating.
Okay, I think I'm starting to get it. Breaking down language, analyzing words, machine learning to teach computers how to understand us. So what are the core parts of NLP that make all these crazy applications possible?
There are two: natural language understanding, NLU, and natural language generation, NLG. Like two sides of the same coin. NLU is about comprehension, machines understanding what we say or write. NLG is about expression, teaching machines to create language. That makes sense, and is relevant to the situation.
So NLU is computers understanding us, and NLG is them talking back.
Yeah, that's a great way to put it. So let's say you ask your voice assistant, add milk to my shopping list. NLU lets it understand that, even though you didn't use specific commands or keywords.
And then NLG is what makes the assistant say, okay, I've added milk to your list. Anything else?
Exactly. It takes what it knows, your request, and turns it into something you can read, a response that makes sense in the conversation.
This is incredible. So we've got these two powerhouses, MLU and NLG. What are some real-world examples of how they're changing the game right now?
Well, chatbots are a big one. And I don't mean those basic ones that just answer simple questions. We're talking AI-powered. That can hold conversations, understand complex requests, even learn from the interactions. They're used in customer service, healthcare, education, you name it. even entertainment.
So the next time I'm like chatting with customer service online, I could be talking to a robot and not even know it.
It's definitely possible. And get this, those neural networks we talked about, they can be fine-tuned for specific jobs with just a little bit of data. Sometimes a few hundred examples is enough to make them really good.
Really? That's amazing. So they're not just learning language generally, they can become like specialists.
Absolutely. Imagine a company takes a language model and they fine-tune it on their product manuals and customer support transcripts. Now they have a chatbot that can answer questions about their specific products and services.
Like giving the chatbot a crash course in their field. That's impressive.
And another area where NLP is making a difference, language translation. Google Translate, we've all used it. Those neural machine translation models, they're getting really good at capturing the nuances and creating translations that are accurate and sound natural.
So we're talking translations that actually sound like a person wrote them, not a machine.
That's the goal. And the progress has been incredible. Think about it. Real-time conversations with people all over the world, breaking down those language barriers, building understanding.
I love that. NLP as a tool for connection.
It's a powerful idea. And speaking of power, NLP is also big in social media analysis. Think of all the data generated every second. NLP helps make sense of it all. Businesses, researchers, they can use it to get real insights from all that chatter.
So instead of just like scrolling through endless feeds, businesses can actually understand what people are saying about them, their products, the competitors even.
Exactly. They can analyze posts, understand how people feel, spot trends, track brand mentions, even predict what customers might do. It's a whole new level of insight.
Wow. I had no idea NLP was being used in so many ways.
And we're really just getting started. So many more applications to explore.
It's been an incredible journey so far, but before we finish this part of our deep dive, I have to ask, with all this progress, are there, like, challenges? I mean, human language is really complex.
You're right. There are definitely challenges. One of the biggest is just how ambiguous language can be. We humans, we use context, tone, even body language to understand each other. Computers don't always have that, which can lead to, mix-ups.
Yeah, I guess we're still working on making computers as good as us at, like, reading between the lines.
Exactly. Another challenge is data scarcity, especially for languages that aren't, as represented online. Most research focuses on English, Mandarin. So there's a lack of resources for many other languages.
So there's still a lot of work to do to make sure NLP benefits everyone, no matter what language they speak.
Absolutely. And speaking of the future, there's a lot of buzz about quantum computing and how it could revolutionize language processing.
Quantum computing. Okay, now that sounds straight up futuristic. What could that mean for NLP?
Quantum computers could potentially solve some of the most complex NLP problems way more efficiently than our regular computers. We're talking analyzing huge amounts of data, understanding the tiniest nuances, even generating text that's basically indistinguishable from human writing.
Wow. So next level language processing, powered by like quantum mechanics?
It's a possibility. Of course, quantum computing is still pretty new, but the impact on NLP is definitely something to watch.
This has been a whirlwind. I feel like we've only just begun to explore this world, but I'm definitely ready for more. Where do we go from here?
Well, next time, we'll get more technical. We'll look at syntax analysis, semantic analysis, and the world of word embeddings. That's a fascinating one.
Can't wait. Until then, keep those brains buzzing.
Welcome back to our deep dive into NLP, natural language processing.
Picking up right where we left off, exploring how computers are learning to understand, even speak our language.
Yeah, and we saw in part one, this tech is already huge. It's impacting our lives, even if we don't always realize it.
Totally. Last time we talked about the core parts of NLP, natural language understanding and natural language generation.
Right, and how those amazing applications like chatbots, translation tools, and those voice assistants, we all use them.
For sure. But today we're going deeper. I want to get a glimpse of like the engine that makes all this possible.
Like we're popping the hood,
right?
Looking at the machinery that lets computers process and get human language.
I'm ready. Let's do it. So where do we even start? How do you teach a computer something as fluid, as complex as language?
It all starts with breaking it down into smaller pieces, manageable pieces. Kind of like if you take apart a complex machine to see how each part works.
Right. And I remember from that YouTube video we have, this is called tokenization, right?
Yes. Tokenization is like the foundation. It's splitting text into individual words, phrases, even punctuation marks. We call those tokens Each one becomes like a data point for the computer to analyze.
So it's like building a vocabulary list for the computer, giving it the building blocks for understanding.
That's a great way to think about it. And once we have the tokens, we can start to analyze them based on their grammar roles. That's where part of speech tagging comes in.
Part of speech tagging. So that's figuring out if a word is a noun, a verb, an adjective, all of that.
You got it. It's like we give each word a label. Tells the computer what it does in the sentence, helps it understand the structure, the relationships between words.
So instead of just a jumble of words, the computer starts to see the sentence as a meaningful unit with structure, grammar.
Exactly. And once we've got the words tagged, then we can do even more, like named entity recognition.
Named entity recognition. That sounds like, I don't know, something out of a spy movie or something.
Maybe a little. But it's incredibly useful. It's all about finding and classifying those named entities in text. So people, places, organizations, dates, things like that.
Got it. So like if I'm reading a news article about, let's say, a company's earnings report, named entity recognition could help the computer pick out the company name, the CEO, the key figures, right?
Exactly. It's like giving the computer a highlighter and say, hey, pay attention to these parts. This is the important stuff. It's crucial for summarizing documents, answering questions, even pulling out information to build databases.
Wow, I'm seeing how this all connects. We're taking language apart, labeling the pieces,
Yeah.
then using that information to extract meaning and insights.
It's a pretty amazing process, and it's all powered by these really sophisticated algorithms and machine learning models.
Speaking of algorithms, I remember from part 1, we talked about neural networks. Those sounded, I gotta say, pretty mind-bending. Can you remind me what those are all about?
Sure. Neural networks are a type of machine learning model inspired by the structure of the human brain. Layers of interconnected nodes, information flows through them, so the model can learn from data and make predictions.
So it's like a digital brain that can learn and adapt like ours.
That's a good way to put it.
Yeah.
And for NLP, neural networks have been incredibly successful. Tasks like translation, text summarization, even creating things, creative text formats like poems or code.
It's pretty wild to think that computers are getting so good at things that, well, we thought were, uniquely human.
I know, right? And one of the most exciting things in NLP right now is the rise of these transformer models, a special type of neural network. Super successful at translation, text generation, all sorts of things.
Transformer models. Those sound familiar. Aren't those the models behind some of the AI tools that can write whole articles, even compose music?
That's right. Models like BERT, GPT-3, they've been making headlines. They can understand the context of words within a sentence really accurately. And that lets them generate text that's really high quality, almost human.
It's fascinating, but also, I gotta say, a little bit unnerving, thinking computers can almost mimic human creativity like that.
I get it. It's powerful tech, and we got to be thoughtful about it. But it also opens up amazing possibilities to boost human creativity, make us even more productive.
Okay, I'm trying to stay open-minded about the whole AI writing thing, but how do these transformer models actually work? What makes them so special?
One of the big innovations is how they process information. It's parallel.
Yeah.
So unlike those traditional neural networks, which go step by step, transformers can look at a whole sentence at once, capturing the relationships between words much better.
So instead of reading word by word like we do, they can grasp the meaning of the whole thing in one go.
Exactly. And that lets them understand the context of words so much better. Crucial for things like translation, text generation.
Like they're seeing the big picture, not just the individual pieces.
Yeah, great way to put it. And another key thing with transformer models is they use attention mechanisms.
Attention mechanisms. Okay, that sounds interesting.
It is. They allow the model to focus on the most important parts when it's making predictions. So, for example, when translating, it might pay more attention to certain words or phrases, the ones that are really key for getting the meaning across.
So it's like they're learning to prioritize the most important info, just like we do when we're reading or listening.
Exactly. That ability to focus, it's a big part of why transformer models are so effective.
This is incredible stuff. Before we go on, I want to go back to something you mentioned earlier, word embeddings. That one caught my ear. What are those all about?
So word embeddings are a way to represent words as vectors, which are basically lists of numbers. These vectors capture the meaning, the semantic meaning of words, allows computers to understand how words relate in a way we couldn't do before.
So instead of just seeing words as like random symbols, we're giving them a mathematical representation that captures their meaning, how they connect to other words.
Exactly. And it's really changed NLP, revolutionized it. We can do things like measure how similar words are, find synonyms, antonyms, even understand analogies.
So if I tell the computer, like, king is to queen as man is to woman, it could use word embeddings to get that.
Exactly. It's like giving the computer this deep understanding of how words relate, allows it to reason about language in a much more sophisticated way.
This is mind-blowing. We've covered so much in this part of our deep dive. We went from like the basic stuff, tokenization, to neural networks, transformer models, all this complexity. Anything else we need to know before we wrap up part 2?
I think we've got the fundamental building blocks down. You've got a great grasp of how these techniques work together to let computers process and understand human language.
I feel like I've learned a whole new language myself. Haha.
I bet you have. And now that we've got this foundation, we can start to look at some of the bigger questions around this tech.
Questions about like the future of NLP and how it's going to impact our lives.
Exactly. Join us next time for part 3. We'll be diving into the ethical stuff, all the considerations around this powerful technology, and what it means for humanity.
I can't wait. Until then, keep those brains buzzing. Welcome back to the deep dive. Final part, our exploration of NLP, natural language processing. Excited to see where we end up.
We've covered a lot, haven't we?
Yeah.
In the first 2 parts, from like the basics of language
Okay.
to neural networks, transformer models, all that.
It's been a journey for sure. We've seen how NLP is being used in some amazing ways. Chatbots, translation, those AI assistants we all use.
Right. But now I think it's time to kind of shift gears, tackle some of the bigger questions around this tech.
Exactly. It's not enough to just like be wowed by how it works. We got to think about the implications, how it might change things, the world.
Absolutely. Like any powerful tool, NLP comes with responsibility. You've got to use it wisely, thoughtfully.
So where do we even begin? What are some of those key things to consider when we talk about the impact of NLP?
One of the big ones is the job market. We've talked about how NLP can automate tasks, things humans used to do.
Yeah.
Writing reports, translating, all that.
Right. And that makes people wonder about like jobs disappearing, the future of work. Some people worry that NLP will mean robots take our jobs, lead to unemployment.
It's a valid concern, but technology has always been disruptive throughout history, right? New technologies, they create new jobs, but they also make some jobs, obsolete. It's the way of things.
That's true. It's not necessarily about like robots replacing us. It's more about how jobs change as technology evolves.
Exactly. NLP is no different. It might automate some things, but it'll also create new opportunities in areas like data science, AI development, all those NLP-related fields.
So instead of like fearing the robots, we should focus on adapting, learning the new skills. That'll be in demand.
Couldn't agree more. And this is where I think governments and schools have a huge role, investing in training, giving people the skills to thrive in this new world, this AI-powered world.
Absolutely. We got to make sure everyone has the chance to benefit from these advancements.
And beyond just jobs, there are, bigger societal things to consider, like how NLP might affect how we talk to each other, how we communicate.
That's an interesting thought. If machines get really good at understanding and generating language, do we risk becoming like overly reliant on tech for communication?
It's possible. We might start losing some of those essential human skills. Empathy, listening, being able to read between the lines.
So we have to use this tech in a way that helps communication, improves it, not replaces it.
Exactly. We need to use NLP to bridge those gaps, build understanding, create a world that's more inclusive.
And that kind of brings us to another point. NLP and shaping public discourse is already being used to analyze social media, track how the public feels about things.
Right, and that's led to some worries about manipulation, misinformation spreading, especially on social media where algorithms can make some voices louder while others get silenced.
So we got to be aware of those risks, promote responsible use of this technology.
Absolutely. Transparency, accountability, ethics, all of that needs to be front and center as NLP keeps developing.
We got to make sure this tech empowers people, not, controls them.
Couldn't agree more. This isn't just about tech. It's about humanity.
This deep dive has been, a real eye-opener for me. And I feel like we've just scratched the surface.
It's a huge field, changing so fast. Always more to learn.
We've talked about the amazing potential of NLP, but we also got to remember to use it wisely, ethically.
Because at the end of the day, the future of NLP,
Yep.
it's in our hands.
It's up to us to shape how it's developed, how it's used.
Thanks for joining us on this deep dive into NLP, natural language processing.
And until next time, keep those brains buzzing